Anthropic just blew past OpenAI in revenue as the AI power shift accelerates. Anthropic just blew past OpenAI in revenue. Meta is reportedly preparing its first Alexander Wang-led AI models, and OpenAI is warning the federal government that artificial intelligence might actually break the social contract. If you're trying to keep up with the latest models, you already know things move insanely fast. Welcome to iNuQ.com, AI news you can use, your daily dose of AI know-how. Let's get right into the reality of April 2026. Because the power dynamics between the major AI labs have completely shifted in just the last few weeks. We have to start with Anthropic. The revenue numbers are staggering. They just overtook OpenAI in revenue, hitting a $30 billion annual revenue run rate. To put that acceleration in perspective for you, they were sitting at roughly $9 billion at the end of 2025, and they added roughly $11 billion in annualized revenue in just over a month. That is equivalent to the combined ARR of Palantir, Anduril, and Databricks. And to be clear, $30 billion ARR isn't a one-off licensing deal. That is annualized recurring revenue, hard locked-in subscription money from massive enterprise clients. In less than 2 months, Anthropic doubled the number of enterprise customers spending more than $1 million a year, going from over 500 to more than 1,000 corporate clients who are basically making Claude their entire operating system. But here is where the financial paradox gets wild. Even with $30 billion in recurring cash flow, Anthropic is actively projecting that 2026 will be their biggest loss year on record, and they aren't expecting to hit actual profitability until 2029. If you have $30 billion coming in with traditional software margins, you should be printing money. But they aren't a traditional software company anymore. That money is going directly into the physical earth, into copper, silicon, industrial cooling systems, and power plants. Anthropic just expanded a massive partnership with Google and Broadcom to access 3.5 gigawatts of compute capacity starting in 2027. 3.5 gigawatts. A gigawatt is roughly the power capacity needed to run a mid-sized American city. They are building physical infrastructure on a scale that rivals federal works projects. And what's crucial to understand is the specific hardware they're deploying here. They aren't just buying off-the-shelf general-purpose graphics processing units or GPUs anymore. This multi-gigawatt deal is heavily focused on Broadcom-designed TPUs, tensor processing units. This is a massive strategic divergence. A GPU is fundamentally a generalist. It was originally designed to render polygons for video games and just happened to be very good at the massive parallel processing that neural networks need. But a TPU is an ASIC, an application-specific integrated circuit. It strips away all the rendering silicon and graphical overhead, focusing purely on the matrix multiplication required for AI math. By securing 3.5 gigawatts of TPU capacity, Anthropic is locking in an incredibly optimized, highly efficient supply chain, hedging against the GPU monopoly to gain a massive pricing and performance edge. But even with all that custom hardware efficiency, the infrastructure costs are clearly biting them. We just saw Anthropic abruptly cut off flat-rate subscription usage for Claude Code inside third-party developer harnesses like OpenClaw. If you were using OpenClaw, whose creator, Peter Steinberger, recently joined OpenAI, your flat-rate subscription no longer works for those tools. You are now forced into a pay-as-you-go API tier. Anthropic's Claude Code lead, Boris Cherny, claims this is purely about infrastructure limits and managing server loads so they can keep serving customers long-term. But the developer community is reading between the lines. There is a strong suspicion that Anthropic is intentionally creating friction to force users out of open-source tooling and directly into Anthropic's own proprietary coding environments like Dispatch. Honestly, it really comes down to the math of the agentic shift. Think about how we used to use these models. You type a prompt, hit enter, read the response. The compute load is mostly quiet because human typing speed is incredibly slow. But developers are now plugging Claude into autonomous agent harnesses. An agent doesn't stop and read. It runs a loop where it queries the model, writes a function, tests it in a virtual terminal, reads the error log, and queries the model again to rewrite it, doing this 50 times a second. Those flat-rate subscriptions were modeled for human typing speeds. not autonomous software loops consuming tokens at machine speed. Anthropic was hemorrhaging compute, and they had to plug the leak. This compute squeeze is impacting everyone, including OpenAI. They are sitting at a reported $25 billion ARR, which is massive, but suddenly they're trailing Anthropic. The burn rate is what keeps their board awake at night. OpenAI expects to burn a total of $85 billion in 2028 alone, and they don't see the break-even point until 2030. That is an agonizingly long runway. And because of that, there are intense rumors of friction between CEO Sam Altman and CFO Sarah Friar regarding the timing of a potential IPO to raise more capital. When you look at their cap table, that internal gridlock makes perfect sense. We tend to think of OpenAI as an extension of Microsoft, but Microsoft only holds 26.79%. The original nonprofit foundation controls 25.80%. Employees hold a massive 19.35%. Then you have SoftBank at 11.66%, Amazon at 4.66%, Nvidia at 3.47%, and other investors. You have employees desperate for liquidity, SoftBank needing hypergrowth, Microsoft wanting an engine for Azure, and a foundation supposed to be guarding humanity. This structural tension brings us to the ongoing leadership drama surrounding Sam Altman. Recent investigative pieces in The New Yorker have surfaced unseen memos from Ilya Sutskever and private notes from Dario Amodei, both foundational to the company, before they exited. The allegations describe a long-running pattern of deception regarding safety protocols and internal board communications. For anyone navigating the tools these companies build, this raises a fundamental issue of trust. What happens to the culture of a near-trillion-dollar company when its founding peers document a history of strategic deception by its chief executive? It creates a massive trust deficit. People start second-guessing every release. I think that trust deficit is the exact reason OpenAI just made a bizarre acquisition, buying a massively popular tech and business podcast network. On paper, it makes zero sense. But it's not a technology play. It's a direct media channel strategy. Traditional media has been aggressively critical of OpenAI, and leadership clearly distrusts traditional journalism right now. By acquiring a beloved podcast network, they are buying an unfiltered audio channel directly into the ears of founders, investors, and policymakers, bypassing the gatekeepers entirely to control their own narrative. While OpenAI fights PR battles, Meta is taking a completely different approach under their new chief AI officer, Alexander Wang. After Llama 4 underwhelmed against top rivals, Meta is pivoting hard. They are pushing heavily into the consumer market, trying to make AI native to their social apps. But their architectural strategy is shifting to a hybrid model. Mark Zuckerberg has been the ultimate evangelist for open source AI, but commercial reality is hitting the manifesto. Meta is preparing to open source their smaller edge device models, but they are keeping their absolute largest, most computationally expensive crown jewel models closed and proprietary. It's the classic razor and blades model, updated for the intelligence age. They give away the smaller models to hook developers into their ecosystem and syntax. But if you want the cutting-edge reasoning capabilities for complex enterprise tasks, you have to pay the toll and use the closed API. It's like giving away the steering wheel, the tires, and the chassis for free, but putting a heavy-duty titanium padlock on the engine block. The era of mega corporations altruistically dropping trillion-parameter frontier models for free is closing, because the physical cost of training them has become completely unsustainable. Here is how neurosymbolic AI actually works. For a decade, we've relied on deep neural networks, which are incredible at fuzzy pattern matching by statistically guessing outcomes from billions of examples, but they are terrible at hard, formal logic. Symbolic AI is the exact opposite. It's the old-school approach of writing explicit, rigid rules. Neurosymbolic AI smashes them together. It gives the intuitive pattern matcher a hard rulebook to follow from second one, constraining the statistical guessing game with absolute physical laws. Imagine training a robotic forklift to organize a warehouse. A pure neural network will randomly crash into steel shelves millions of times because it has to statistically learn that driving into a wall results in a negative reward. With neurosymbolic AI, you give the robot the mathematical rules of gravity and momentum first. It already knows it cannot drive through a steel beam, So the neural network only has to spend its compute power learning the intuitive stuff, like recognizing irregular box shapes. It's an incredibly elegant efficiency leap, and it's this stabilization at the foundational layer that is enabling the software transition we are witnessing right now. The chatbot is dead. We are officially deep into the agentic shift. Both PwC and Deloitte just released their 2026 enterprise forecasts, and they have officially declared the era of generative AI is over. We have transitioned fully into agentic AI. Generative AI was a tool of creation. You asked it to draft an email, but you were still the manager. Agentic AI is about autonomous execution. Enterprises are tearing out chatbots and replacing them with autonomous workflows that manage supply chain logistics and HR onboarding with virtually zero human oversight. The developer agents dropping right now are terrifyingly capable. Google just released Jules V2, codenamed Jitro. You no longer give the AI step-by-step tasks. You give it high-level, business KPI-driven goals. You literally tell the agent, optimize the database architecture to reduce API latency by 15%. The agent figures out the necessary steps, writes the SQL refactor, tests it against a dummy database, catches its own errors, and deploys the optimized code. Devin 2.2 is doing the exact same thing, spinning up virtual desktops to test its own engineering. But if you've ever managed a production code base, this makes you panic. What if it decides the best way to hit that engagement metric is to break the UI and force users into an infinite redirect loop? That is the defining problem of agentic AI, the alignment of trust and verification. The industry is solving it with architectural oversight, like GitHub's new rubber duck mode. It introduces a dual model adversarial architecture. One AI model acts as the junior developer writing the code, but before anything is committed, a completely independent, differently trained AI model acts as the senior code reviewer. It actively critiques the code, tests edge cases, looks for security vulnerabilities, and tries to catch hallucinations. Having models rigorously verify each other drastically reduces human supervision required. And this agentic capability is trickling down to everyday users incredibly fast. Let's look at the Blogger's Toolkit. Cursor 3 just launched with a standalone window for local-to-cloud agent handoffs. You have a local, lightweight open-source agent doing formatting on your machine, and when the logic gets too complex, it seamlessly hands the context window off to a massive cloud-based frontier model, then pulls the finished code back. Adapt is essentially a synthetic employee living inside your Slack workspace, accessing live CRM data to build custom mini-apps in real time. Clicky is an AI teacher that attaches to your mouse cursor. It uses computer vision to watch your screen and guides you through complex UI like a real tutor. Interpreter and CoreWorks are desktop agents where you drag and drop a folder of messy ERP data and unstructured PDFs, and they instantly format a clean, auditable slide deck and executive report. And that financial unsustainability crashes directly into physical reality. We are looking at a potential $7 trillion cost for global AI infrastructure over the next few years. Last year alone, AI systems and data centers consumed 415 terawatt hours of power. That is more than 10% of total U.S. electricity production, and demand is projected to double by 2030. We are hitting severe macroeconomic limits. It's not just getting the GPUs, it's finding the skilled electrical workers to wire the facilities. It's securing the millions of gallons of water required to cool the server racks. It's a massive global shortage of copper for high-voltage transmission lines. You literally cannot manufacture and install enough electrical substations fast enough. But some players are trying to bypass these traditional constraints by building entirely new parallel ecosystems. Look at the Terafab complex currently being built in Austin, Texas. Intel just partnered with Elon Musk's xAI, Tesla, and SpaceX to build a massive sovereign supply chain. The scale of Terafab is terrifying. Their stated goal is to produce 1 terawatt of compute capacity annually, entirely dedicated to AI, robotics, humanoid systems, and space-based infrastructure. Why partner with Intel instead of the dominant GPU vendor? It's about escaping the margin capture of a monopoly. By partnering directly with Intel for custom chip design and leveraging Tesla and SpaceX's manufacturing, Musk is trying to build a self-contained, vertically integrated AI hardware stack. From the silicon sand going into the foundry to the humanoid robot walking out of the factory door, the ripple effects of this hardware scramble are supercharging the entire supply chain. Samsung just reported an eightfold profit jump driven entirely by the insatiable demand for AI chips and memory bandwidth. Uber is actively migrating massive chunks of their AI routing workloads off traditional hardware and onto Amazon's custom-designed inference chips. Everyone is hunting for an efficiency edge. But efficiency isn't just about the processor. The connective tissue is failing. We are seeing a massive networking bottleneck. Area Networks just raised $125 million specifically for AI networking, and Firmus raised $505 million for data center construction architecture. You can buy 100,000 of the fastest chips on the planet, but to train a frontier model, those chips have to act as a single brain, constantly sharing data in fractions of a millisecond. If the fiber optic network linking them isn't fast enough, your multi-million-dollar chips just sit there idling. It's like having a Ferrari engine, but being stuck in bumper-to-bumper traffic. This is exactly why the industry is desperate for architectural breakthroughs that don't rely purely on brute force scaling. We might be seeing a sustainable savior emerge in the form of neurosymbolic AI. Researchers just built a neurosymbolic AI specifically for visual language action robotics, and the benchmark results are astonishing. In tests using the Tower of Hanoi puzzle, it achieved a 95% success rate, completed its training run in just 34 minutes, and used a tiny fraction of the energy of a traditional model. For context, a standard deep learning system took a day and a half to learn the exact same robotic tasks and only hit a 34% success rate. This automation is hitting the physical world. A new Cisco report states that 61% of industrial firms have officially moved AI out of the pilot phase and into live physical operations on the factory floor, though 40% admit they are terrified of the cybersecurity implications of AI controlling heavy machinery. In healthcare, OpenAI is processing 2 million insurance-related messages weekly. A company called Legion Health just got their AI approved to refill psychiatric medications entirely without clinician oversight. But patients are fighting back. Places like the Cleveland Clinic are dealing with patients demanding to opt out of AI scribes due to massive data privacy fears. Doctors love it for efficiency. Patients are terrified of where that audio goes. The internet itself is buckling. SEO firms are now trying to mathematically inject clients into the latent space of the models. Zoopal just raised $130 million to physically map the Earth so AI models can understand geospatial relationships. And for personal data, we have two radically different philosophies emerging, known as the Carpathy debate. One is a highly structured wiki-style approach. The other is the Farsapedia approach, where creator Farsa dumped 2,500 raw, unstructured diary entries and messages into a flat database and let the AI agents synthesize the chaos on demand. It's the ultimate delegation of memory to a machine. And as these systems become our literal infrastructure, the legal warfare is escalating. OpenAI has petitioned attorneys general to investigate Elon Musk for anti-competitive behavior and bad faith litigation to stall OpenAI while he props up XAI. Meanwhile, a U.S. federal court just struck down the government's attempt to ban anthropic models in public agencies, establishing a doctrine of AI sovereignty for public infrastructure. But the geopolitical threat is terrifying. Iran's military just published satellite footage of OpenAI's massive $30 billion Stargate data center project in Abu Dhabi and explicitly threatened to destroy it. We've moved from software patents to literal missile threats against data centers. Compute is the new uranium. Before we get into the final takeaways, just a reminder that you can find more insights and resources like this at inuku.com. To summarize everything we've covered today, we have officially exited the generative AI era and entered the agentic shift, where tools like Jules V2 and Devin 2.2 are executing complex multi-step goals autonomously. But this capability is crashing into the harsh reality of physical physics. The global power grid, copper supply, and networking bandwidth are buckling under the weight of AI's multi-gigawatt appetite, pushing companies toward massive vertical integration and new architectures like neurosymbolic models. Ultimately, as models become capable of flawless, mundane visual forgery and entirely autonomous labor, we are facing a massive societal trust deficit that is forcing a total rewrite of corporate structures and government policy. We are watching the rapid privatization of human cognition. The question is, are we building tools to elevate ourselves, or are we building our successors? And that's your daily dose of AI know-how from inuku.com, AI news you can use. The biggest takeaway today is that the compute bottleneck is real. The agents are here, and the economy is shifting faster than the regulations can keep up. Stay curious, stay ahead of the curve, and we'll catch you next time.